This is a short video about Chapter 4 of Stein's elementary number theory book, and this whole chapter is dedicated to the idea of quadratic reciprocity. And in this video, we'll just introduce what the idea is. And so to motivate what's going on so far, what we spent some time doing was how do we solve linear congruences, like ax is congruent to b modulo n. And we were able to characterize exactly when that thing has solutions. And if you recall, we said that such a linear congruence has a solution if and only if the GCD of a and n divides b. So whenever the greatest common divisor of a and n divides this b here, that's when you can expect to find a solution x. What we'd like to do is to shift our attention to, can I characterize when like a quadratic congruence has a solution or not? And it turns out that the main thing that we'll look at is just, can I figure out when this a here is a perfect square modulo a prime? That happens to be like a key in order to saying a lot of things about characterizing solutions to this quadratic equation here. And some of the things that we might see in this section in order to address this question, right? So the key question of whether a given integer a is a perfect square modulo p. That'll tell me a whole lot. Maybe it's not necessarily that a, I might have lied to you there. But that'll turn out to tell me a whole lot about the solutions to this quadratic congruence up here. So the big key in this section, like it's aptly named, is the quadratic reciprocity law that Gauss proved back in the 1800s. And here's what Gauss's quadratic reciprocity law says. The main thing it asks is, for what primes p is the image of a in z mod p z star? Just to remind you, what is this? This is the group, the multiplicative group, so multiplicative group of units mod p. So what that is, it's the set 1, 2, 3 up to p minus 1, where it makes sense to multiply elements in the set, and you should get another element of that set after you reduce mod p. And what else? So for which primes p is the image of a, so of one of these guys, a perfect square? So for what primes p, again, is the image of a in this set a perfect square? And that is a big question. And that's what Gauss's reciprocity law, again, aims to help us answer. And it's connected to a pretty important fact in number theory, and it gets pretty deep pretty fast. The answer to that question, for which primes p is the image of a in z mod p z star perfect square, it's connected to what happens when I reduce p mod 4a. And if you think about it, like, wait a minute, what just happened? We're going to reduce p mod 4a. That's related to the reduction of a mod p. So notice how, like, where a and p, they switch spots. That's this idea of reciprocity again. And so again, notice again, I've said notice again a few times. Notice that a and p switch spots in those two statements. In the statement that I have highlighted there, and then also in this other statement that I have highlighted right here. So the fact that these a and p switch spots is maybe motivation for why it's called reciprocity here. And it turns out to be pretty surprising, the answer to that question, which again, the book might get a little bit into way later in this chapter. But to decide if a is a square mod p, again, we just need to figure out if p, what is the residue of p mod 4a? And that's pretty wild, pretty crazy. If you're interested in a lot of this cool number theory stuff, some of the driving problems in the field that still make the field popular and relevant today are class field theory and the Langlands problem. Those are two huge areas in number theory that are under intense research and offer, bounties for progress in those fields. But again, this section really just focuses on what's sort of the main tool for answering this question of, is a given integer a square mod p? We'll look at this again, quadratic reciprocity law. And there's lots and lots of proofs. There's over 100 proofs of the quadratic reciprocity law itself that use like different techniques. In this book, there's just an expose of 2 of them, and we'll actually probably just spend time on 1 of them as we go on. So that is just a short introduction again to the quadratic reciprocity, what the idea is, and in the next few videos we'll try to get comfortable with some of the terminology and definitions, again, in order to attack this question of, when is an integer a square modulo p? Can I characterize that in some way?